Imagine you and your best friend both have identical watches. You hug goodbye, they board a spacecraft headed toward the most terrifying object in the universe, a black hole, and you stay home on Earth. A few years pass. They come back. You check your watches. Yours says 5 years have passed. Theirs? Maybe 2. They didn't break their watch. They didn't sleep through anything. Time itself moved slower for them. And the closer they got to that black hole, the worse it got. This is not science fiction. This is real. And once you understand it, you will never look at time the same way again. So let's talk about black holes. Not the Hollywood version with dramatic music and things getting sucked in like a cosmic vacuum cleaner. The real version. The version that physicists like Brian Greene spend their lives trying to explain to the rest of us. Because here is the thing. Black holes are not just strange. They are reality-bending in a way that makes your brain feel like it is melting. And one of the strangest things they do is mess with time itself. Now, before we get into the black hole part, you need to understand something that Albert Einstein figured out over 100 years ago. Time is not a fixed, steady river flowing at the same speed everywhere. It is more like a river with different currents depending on where you are standing. If you are near something with enormous mass, a planet, a star, or especially a black hole, time flows slower for you compared to someone far away. This is called gravitational time dilation. And yes, it is actually happening to you right now, just at an incredibly tiny scale because Earth's gravity is pretty mild compared to what is out there. Here is how Einstein thought about it. Gravity is not just a force pulling things together. Gravity actually curves the fabric of space and time. Picture a bowling ball on a stretched rubber sheet. The ball creates a dip, a curve in the sheet. That curve is what we call gravity. Now imagine something with the mass of millions of suns compressed into a space smaller than a city. The dip becomes so extreme, so catastrophically steep, that not even light can escape once it crosses a certain point. That point is the event horizon, the point of no return. And as you approach that edge, something wild happens to time. It starts to slow down, dramatically. Here is a thought experiment that Brian Greene loves to use. Imagine an astronaut, let's call her Maya, hovering near the event horizon of a supermassive black hole. She is not falling in, just hovering very close. Now imagine you are watching her from a safe distance far away, through an incredibly powerful telescope. What do you see? You see Maya moving in slow motion. Her hand moves slowly. Her heartbeat is slow. If she waves at you, that wave takes what feels like hours. From her perspective, though, everything is perfectly normal. She waves, she breathes, she checks her watch. Everything feels exactly the same as always. But if Maya could look back at you through her own telescope, she would see you living your life at an insane speed. Days would fly by for you in what feels like minutes to her. Time is not broken. It is just running at completely different speeds depending on where you are in relation to that massive gravitational pull. Now here is where it gets truly terrifying. Let's say Maya gets just a little too close and starts to fall toward the event horizon. From your perspective watching through the telescope, you see her slow down more and more as she approaches. In theory, you would never actually see her cross the event horizon. She would appear frozen in time, like a photograph, as light from her takes longer and longer to reach you. From Maya's perspective, though, she crosses the horizon in a heartbeat. She does not even feel a dramatic moment. There is no wall, no flash, no alarm. She crosses it, and now she can never come back. The gravity beyond that point is so extreme that even moving at the speed of light would not be enough to escape. She is inside now, and time inside a black hole near the singularity, the center, runs so incredibly slowly relative to the outside universe that entire civilizations could rise and fall while she experiences just a few moments. This is what makes black holes philosophically terrifying, not just physically. They challenge our most basic human assumption, that time is something we all share, that everyone, everywhere experiences the same now. But they do not. Two people can be living in completely different timelines just because one of them is sitting closer to something massive. You already experienced this. Satellites in space have to correct for gravitational time dilation constantly. The GPS on your phone would be off by miles every single day if engineers did not account for the fact that time moves slightly faster in orbit than it does on the surface of Earth. That is not a bug. That is Einstein's relativity working exactly as predicted. And Brian Greene makes this point beautifully: the universe does not care about your intuition. It does not care that you think time should be fair and equal and the same for everyone. The universe has its own rules. And those rules say that the stronger the gravity, the slower the clock. A black hole just takes this rule to its absolute extreme. It is the universe showing you what its own laws look like when taken to their logical, unforgiving conclusion. There is something else that keeps physicists up at night when it comes to black holes and time. If you were falling into a black hole and you could somehow send a message back to Earth, as you get closer to the singularity, your signal would take longer and longer to travel against the intense gravity. From Earth's perspective, your messages would arrive slower, more redshifted, more distorted. You would be communicating across a growing chasm in time itself. At some point, your signal would stop reaching us entirely. Not because you stopped sending it, but because space-time itself became the barrier. This is the kind of stuff that makes physicists like Brian Greene say that our everyday experience of time is just a narrow slice of what time actually is. We live in a comfortable zone where the differences are so small we never notice them. But zoom out, get close to something with extreme gravity, and time reveals its true, flexible, almost liquid nature. It bends, it stretches, it slows to a crawl. Near a black hole, time is not just passing differently. It is practically frozen compared to the rest of the universe. So the next time you glance at your watch, just remember, that watch is lying to you in the kindest possible way. It is telling you that time is simple and steady and reliable. But the universe knows better. Somewhere out there, near the edge of a black hole, there is a clock ticking so slowly that 1 second there might equal 1,000 years here. And that is not poetry. That is physics. That is the real universe we live in. If this blew your mind even slightly, go ahead and hit that like button. It genuinely helps more curious people find these videos. Subscribe if you want to keep going down these rabbit holes together. And drop a comment below. If you could safely hover near a black hole and come back to Earth years younger than everyone you knew, would you do it? I genuinely want to know. Because the universe just gave you a time machine, and it is called gravity.